In this particular problem, we are looking at one of my all-time favorites, or at least a version of it. It's patterned after a problem in the Holt Modern Physics book. Well, not modern physics, but physics book for high school students. This involved ships, and I just changed it around a little bit. Changed some numbers around and trajectories. But the gist remains the same, that we have tank over here. We're firing a projectile at 250 meters per second at a 75-degree angle, aiming at a target on the other side, which I've chosen as a Jeep. And in between the two is some kind of hill or mountain. And I've given you some set numbers. The tank is 2,050 meters from the maximum peak of the mountain, and the Jeep is another 1,000 meters on top of that. And the mountain itself has a maximum height of 2,600 meters. Three questions that we are going to look at is by how many meters did the projectile miss? By how many meters did the projectile clear the mountain peak? And finally, the part of the problem that the Holt book doesn't ask, which is unfortunate because it's in my opinion, the best part of the overall problem, is at what angle must the projectile be fired to actually hit the Jeep or target on the other side. So if we just draw some stuff here, we know that we're going to fire this, going to go over the mountain, and let's say it does something like this. I'm going to say it overshoots it. I don't know if it does or not. We'll find out here in a little bit. It could undershoot. The drawing isn't important. The concept's important, and the math will figure us out. So, question one, by how many meters did the projectile miss? Well, the first thing we probably ought to do is figure out how far away the Jeep is. And so the total displacement from the Jeep to the tank is 2,050 plus 1,000. And so the total displacement to the Jeep is 3,050 meters. I'm going to go ahead and delete the questions, or at least move them away here for a little bit. We'll put them over here for the time being in order for us to talk about these. So if I start with that concept right there, and let me bust out some equations here. So we have displacement in the x direction is equal to the velocity in the x direction times time. Well, the velocity in the x direction would be that black line right there on the tank, and so the displacement in the x direction would be the launching speed of the projectile, which is 250 meters per second, times the cosine of 75 times time. So I don't know what the time is, but I also don't know what the dx is, because I know that the Jeep is 3,050 meters away, but I don't know how far away the projectile goes. So I need to figure out what the displacement of the projectile is. I need to solve for dx, but I don't know the time. So we need something else to figure out the time for us. And so let's go to another part of this here. Hold on here, having technological issues here. Doesn't want. There we go. So the next thing I'm going to take a look at is the projectile motion equation. Displacement in the y direction is equal to 1/2 gt squared plus the initial velocity in the y direction times time. Now, when the projectile goes throughout its entire path and lands over here on the other side, the displacement in the y direction is 0. So dy is 0 is equal to 1/2 gt squared plus the initial velocity in the y direction would be the launching speed of the projectile, 250, and it's the opposite side, so that's the sine of 75t. I don't know t, I know everything else in this, and it's time to solve it. And a lot of people kind of start to freak out. They're like, oh my gosh, this is a quadratic equation, but it actually is pretty easy. Something nobody ever thinks about, let me undo that. Something nobody ever thinks about is factoring. And so if I factor out a t here, I'm left behind with 1/2 gt, because I factored out a t, it's no longer squared, even though I just about tried to write it, plus 250 sine 75. So the projectile is 0 meters high at time t, so this equals 0, the t does, which obviously it hasn't moved yet, it hasn't been fired, so at time 0, sure, the displacement of the projectile is 0. So that's not the solution we are interested in. We are interested into the solution of this right here, which is our stuff inside the parentheses. So let's set that equal to 0. So 0 is equal to 1/2 gt plus 250 sine 75. Let's subtract the 250 sine 75 over to the left-hand side, and that is equal to 1/2 gt. I've got one thing to solve for. Let's multiply by 2. So negative 250 times 2 is 500 sine 75. I'm going to divide now by g, and that is equal to the time. So now we'll bring up a calculator here, and we'll do some computation. And so I've got negative 500 sine, this looks like 15 on my page here, but it's actually a 75. So sine 75 and divide by negative 9.81. And when you get better at this, you'll figure out, well, the signs will cancel, so I'll just plug in positives all over the place. I won't worry about those, but we'll try to calculate as best we can, and we get about 49 seconds, 49.23. So 49.23 seconds for the object to be in the air. Now, let's go over here, and let's grab this, and let's bring down here 250 cosine 75t. So, dx is 250 cosine 75t. I know what my t is. My t can go directly into, boom, right there. And so I've already got dx solved for, so let's calculate it. 250 cosine 75 and times my previous answer. I won't even introduce any rounding error. The displacement is 3186 meters. So dx equals 3186 meters. Now that's not our answer. The answer we're looking for here is by how many meters did the projectile miss? Question number 1. So the Jeep itself is 3,050 meters away. So I got to subtract that off. So 3,050 meters away, and so we get a miss of about 136 meters total. So we're going to call that delta D is equal to 136 meters. That was our misfire. All right, we're going to take a brief pause here while I set up for the second part of the problem and get a whole new board here going. All right, question number 2 is about how high did the projectile clear the mountain peak? So what are we talking about here? Well, if the projectile is following the dotted purple line and lands on the other side of the Jeep, then we're talking about this distance right here from the mountain peak to the height right here. Now that mountain's not right smack in the middle. So how do we go about figuring that out? Well, what we do know is we do know how far away the tank is from the maximum altitude of the mountain, which is 2,050 meters. So I know a displacement in the x direction. Let's again move the questions over here. So I know displacement in the x direction. So dx is equal to 2,050 meters. And so if I apply my displacement in the x direction equation, I would have, again, 250 cosine 75 times t. But I don't know what the t is, but I can solve for that. right off the bat here, and I can figure out the time it takes to get there. And once I figure out that time, then I could use the dy equation and see how high it is. So that's pretty straightforward. So let's figure out what dx is. I'm sorry, we know what dx is. We can just plug it in here because it's 2050 is equal to 250 cosine 75 degrees times t. And so let's go ahead and figure out what t is. It would be 2050 divided by, I'm going to wrap everything in parentheses here to make sure that it's all underneath the divisor. So 250 cosine 75, double wrap the parentheses there. Everything's good to go. It takes about 32 seconds or so, 31.68. I'm not going to round anything off right now. So 31.68 is my time. Time is equal to 31.68 seconds. So I know the amount of time it takes to get right here to the mountain peak. Now all I have to do is use my other equation that I know. Displacement in the y direction is equal to 1/2 gt squared plus the initial velocity in the y direction, just like before, was 250 sine of 75 times t. And this is just now really plug and chug. That's pretty straightforward. Not difficult at all. So let's figure out how high the projectile is at 31.68 seconds. So 0.5 times negative 9.81 times previous answer squared plus 250 sine 75 degrees times previous answer. And my projectile is 2,727 meters high. So 2727 is the displacement in the y direction. 2727 meters. Now that's how high the projectile is. I want to know by how much it missed the mountain. And the mountain itself is 2,600 meters tall. And so I subtract 2,600. And so it looks like I get a difference of 127 meters. Is by how much it missed the mountaintop. All right, again, we'll be taking a pause. As soon as I figure out the best way to do that. And we will approach the third part of the problem, which is what angle do I have to fire to actually hit the Jeep on the other side. All right, our third and final part of the problem is about what angle must the projectile be fired to actually hit the Jeep. So 75 degrees didn't cut it, missed the Jeep. So we're going to try to calculate the distance required, the angle required to actually cover the distance that we need. Now, this is a fairly complicated part of the problem, and honestly just takes a lot of math skills. Lots of good algebra in here. So let's figure out what we know. We know that the Jeep is 3,050 meters away. So the displacement in the x direction is 3,050 meters. I know the displacement in the y direction when it hits the Jeep, since it's starting and stopping at the same vertical place, is 0 meters. And so let's go back to our equations and let's figure out what I can figure out on this. So the first thing I'm always going to do is I'm going to go to my dx equation because it's the easiest. So dx is equal to 250, and the projectile is going to fire at the same speed no matter what angle we're going to do this at. So it's going to be 250, and I guess what I should do is scratch out that 75 degrees. That way I don't get confused myself, because it's no longer 75 degrees. Actually, I think I just deleted it right here. So we'll delete that out of there. We don't know what theta is, so we're going to just go in and replace it with a theta. What is that theta? So 250 times the cosine of our unknown angle theta times t. We don't know the time it's going to take to get there either, because we've changed the angle on this a little bit. And so I can't use this equation, even though I know what dx is. I don't know theta, I don't know t. So now it's time to go and look at our other equation, which is displacement in the y direction, is equal to 1/2 gt squared plus the initial velocity in the y direction would be 250 sine of our unknown angle times time. And it kind of looks like we're stuck. I know that dy is equal to 0. I know that dx is equal to 3050. I'm going to go ahead and erase my dx's and my dy's and go ahead and put those numbers in there that I know, since I actually do know them. So this is 3050, and this is 0. It looks like we're stuck, but what we got here is a set of equations. I've got two equations and I've got two unknowns, and you've learned somewhere in algebra or algebra 2 that if you have two equations and two unknowns, there are tricks and techniques to solving that set of equations. What I always go to is substitution. And so what I'm interested in is theta. So I want to preserve theta and I want to get rid of time. So I'm going to substitute time out. I'm going to do that by taking the dx equation and solving it for t. So to solve for t, I make that 3050 divide by 250 cosine of theta, and that's what t is equal to. And then what I'm going to do is I'm going to take that t and I'm going to substitute it in to those two places in the dy equation. So in green now, my equation in y is equal to 0, and that was supposed to be green, and green is clearly highlighted, so not sure what happened there. Let's try that again. There's green. So 0 is equal to 1/2 g. Now I'm going to substitute in my t. I'm going to do this in red. 3050 over 250 cosine theta squared plus 250 sine theta. And I'm getting worried about a room here, so I'm going to grab a hold of all this stuff, move it around here a little bit, and substitute in for t. 3050 divided by 250 cosine theta. Boom. All right, physics done. Problem solved. All we have to do is worry about all the algebra now. And so it's a bunch of cleanup on my math here. So cleaning this up, the first thing I'm going to notice is I have a 250 here and a 250 here. I'm going to cancel those out. So that's going to leave me with sine theta times 3050 divided by cosine theta. And your initial reaction is going to be make the sine of theta and the cosine of theta equal to the tangent of theta. And it ends up that that's actually a little bit of a mistake. We'll undo it here in a little bit and figure out why that is a mistake. But it cleans it up a lot. So I've got 3050 tangent theta in for that. I'm not going to worry about distributing the square right now, and so I'm just going to leave the 1/2 g on the outside, and I've got 3050 divided by 250 cosine theta in parentheses squared. And this is all equal to 0. All right. Let's take the 3050 tangent theta and let's subtract it to the other side. And what I need to do is I need to collect my thetas now. So now I'm just doing some math here to get my thetas collected. So 3050 tangent of theta, and I subtracted it, so that's why there's a negative sign out in front. That has to be equal to 1/2 g times 3050 all over 250 cosine theta squared. All right. Next move, let's multiply everything by 2. And so 3050 times 2 should be 6,100. Tangent of theta. Let's go ahead and divide by, well, no, let's not divide by g yet. Let me undo that here. So I'm going to leave the tangent over here. Is equal to g times 3050. Let's just do the multiply by 2 part and then figure out what the next step is. Cosine theta squared. I have to get the thetas on each side, so I'm going to have to distribute that square through here. I don't see any other way around it from right now. Maybe there is a way, but I can't see it myself. So we're going to distribute the squares around here. So I'm going to leave the left-hand side alone, and so I've got 6,100 tangent of theta is equal to g. We're going to distribute the square, so 3,050 squared divided by 250 squared cosine squared theta. And the squares are distributed. Doesn't look like we're making a whole lot of progress here, but we are a little bit. The g acts as a multiplier, so leaving the left-hand side alone, not touching the 6,100 tangent theta yet. That's tangent. Is equal to, now I can just put the g inside the parentheses, and so I've got 3050 squared times g all over 250 squared cosine squared theta. All right, so believe it or not, it's looking okay. I need to get the thetas on both sides, so the easiest way to do that is to multiply by the cosine squared theta. So negative 6,100 tangent theta, and I don't like how I wrote tangent, so let's undo that. 6,100 tangent theta cosine squared theta is equal to 3050 squared all over 250 squared, and that's where I got it, because that's all I got. I multiplied my cosine over. Here's the next step I'm going to do. I'm going to take that lost a g. There's my g. I'm going to take that 6,100 over to the right-hand side by dividing it, and so I've got nothing but thetas over here. So I'm going to be leaving it tangent theta cosine squared theta is equal to 3050 squared times g divided by 250 squared times negative 6,100. Everything on the right-hand side is now just a number. And everything on the left-hand side involves theta. And you're like, but we have two thetas. Let's worry about that last. Let's go ahead here. And since the right-hand side is now just a number, let's go ahead and just mash that down into an actual number. So I've got 3050 squared times negative 9.81. And it better be negative because I got to cancel a negative there. So we'll get the top divided by 250 squared times negative 6,100. And again, when you get good at this, you can just drop the negatives out of it, knowing that they're going to cancel and they'll be positive, and just treat everything as positive. That's fine too. We better get a decimal answer, and we do. So our decimal answer is 0.2393, which is what I will write down. And you're like, well, how did you know I had to have a decimal answer? Well, if I take an inverse trig function to get an angle, it better be a decimal. So I was expecting to have a decimal in there. So 2393 rounded off. So 0.2393, and I know there's some more left after that, and I will take care of that. So now that leaves us with the tangent of theta. times the cosine squared of theta. And it looks like we're in trouble. And that's because back here at the very beginning when we started this, we did this little thing right here where we simplified the sine theta, cosine theta, and the tangent theta. And I mentioned that that was a mistake. It really wasn't a mistake. It kept everything clean at the time, but now we're going to undo that in order to do some more simplification. So the tangent of theta I'm going to turn back into the sine of theta over the cosine of theta, and then we're multiplying that by the cosine squared of theta, and that equals this 0.2393 number. And you can see now what we did in here. We're canceling a cosine with a square, and so that leaves us now with the sine of theta times the cosine of theta is equal to 0.2393. All right, so everything's looking good right now, except I have that whole sine theta, cosine theta. So I need to look up some trig identities. And so if you know your double angles, it turns out that the sine of 2 theta, and you know what, I'm going to write that somewhere else because I need more space. So it turns out that the sine of 2 theta, in parentheses, is equal to 2 sine theta cosine theta. Now, I don't have 2 sine cosine theta here in red. There's no 2 right there. So I need to kind of simplify it. I'm going to divide the 2 over. And so that means the sine of theta times the cosine of theta is equal to sine 2 theta over 2. Sweet. So I'm going to replace my sine theta cosine theta with that right there. And so sine 2 theta, terrible theta, sine of 2 theta over 2 is equal to 0.2393-ish. Okay, we're down to 1 theta now. This is well within our competence. So sine 2 theta is equal to 2 times 0.2393. And now all I have to do is solve for my theta. And so let's bring up the calculator because we can all do these on the calculator now. So 2 times my previous answer is 0.47-ish. And I have to get inside the parentheses here, so it's time to do an inverse sine. So inverse sine of that answer is 28.6 degrees, but that's equal to 2 theta. So we divide it by 2, and we get a theta of 14.3 degrees. So theta equals 14.3 degrees, and that should be the angle that we hit the Jeep with. But we don't hit the Jeep because the calculator does not know that there's a mountain in the way. If we fire that, we're going to smash into the side of the mountain. We're not going to hit the Jeep. Our angle is too shallow. This is why I wasn't too happy that our textbook ignored this question, because you get an answer here that's mathematically right, and it's just not physically right. So what do we do with our answer? Well, we need to fire it at the complementary angle, not 14.3. Your calculator gives you a result less than 45. So it's going to give you the first result, the smallest one. So we need to fire it at the complementary angle. So 90 minus 14.3. And we need to fire it at 75.7 degrees. So theta really is equal to 75.7 degrees. And then we will hit our target. So the only difference between hitting it and missing it was a mere difference of 0.7 degrees. Jack it up another 0.7 degrees. We will fire. We will hit the Jeep. Boom. Done. Okay? All right. Hopefully that explains some problems and you got some good practice. If you have any questions, you can message me, or my students can text me or email me, whatever you had. Hopefully we learned some things here. Thank you very much.